This is the LISP session number 4. We are going to talk about LISP messages. We're going to include in this session the map register message, the map notify message, the map request message, the map reply message, and the negative map reply message. Let's talk first about the messages that are exchanged between ETRs and map servers. ETRs like to talk with map servers, and map servers reply back to ETRs. So as soon as one ETR detects that it has an interface that connects it to a LISP site, and this interface becomes up, at that moment an ETR is going to send a message to the map server it knows. In this case, we are showing two map servers because we are showing redundancy. In the same manner, this ETR will send a message to these map servers as soon as it detects that this interface connecting it to this EID becomes up. More specifically, the message that we're talking about is the map register message. So ETR send map register messages to map servers. The question here is, what is included within these map register messages? And the information that is included within these map register messages are mappings. Let's illustrate this with an example. So notice that this particular ETR only has one wide area network interface that happens to have this RLOC with this priority and this wait. And notice that this ETR is connected to this EID that we are going to call EID-A. So the map register that this ETR is going to send to these map servers will include this mapping. It will map RLOC number 1 to EID8 with priority 100 and wait 100. Let's put another example. Let's say that this ETR has two wide area network interfaces. This particular wide area network interface happens to have this RLOC with this priority and this wait, and this other wide area network interface has this RLOC with this priority and this wait, and this ETR is connected to this EID-B. Then, for this example, this ETR will send map register messages that include these mappings. RLOC2 to EID-B with this priority and this wait, and RLOC3 with this to IDB with this priority and this wait. Upon receival, the map servers are going to reply back with a map notify messages. So in this manner, ETRs are sure that the previous map register message was received by the map server. So ETR send map register message to map servers, and map servers reply back with map notify messages. Once the map servers receive these messages, they will store these mappings in their database. Remember that this database is known as the mapping database or the site registration table. Notice that as all ETRs report their mappings to the map servers will increasingly know about all the mappings within the LISP domain. Let's talk now about the messages that are exchanged between ITRs and proxy ITRs and map resolvers. What we are going to explain here applies to both to ITRs and proxy ITRs. And let's illustrate this message exchange with an example. Let's say that we have a host here that lives within EID-A that wants to communicate with, let's say, a server that lives within EID-B. We want to make this communication happen. So the traffic will come from this host into this router, and then the router will behave as an ITR. the ITR needs to forward this traffic through the LISP core using a tunnel. However, at this moment, the ITR cannot build this tunnel because it does not know what is the RLOC for this destination ID. It knows the destination ID because it can read the destination IP address within the IP header that just received, but then it needs this information. So what this ITR is going to do is going to ask the map resolver. So it is going to send a query using a map request message. This map request message is basically asking what is the RLOC for EIDB. And then the map resolver is going to look this destination within the mapping database. If this destination exists within the mapping database, that is that this request is adequate or valid, then the map resolver is not going to answer the question. It is going to forward the map request to the adequate ETR. That is the ETR that has this destination connected directly. So the ETR is going to receive the map request because it was forwarded by the map resolver. The ETR is going then to reply back with a map reply message. This map reply message will include the RLOC that the ITR was looking for. Now, after having this RLOC, this ITR is going to store this information in what we call a map cache, and this entry will live here within this cache for 24 hours by default. So in that sense, this ITR is not going to constantly be asking about the RLOC for this destination because it will store this mapping within its map cache. And now, given this ITR knows the RLOC, it can now build the tunnel because it now can insert the destination IP address for the new IP header for this tunnel because it now knows the RLOC. Now, what will happen if after receiving the original map request, the map resolver reached the conclusion that this was an invalid query, probably because the EID was not found within the mapping database. In that case, the map resolver itself is going to reply back using what we know as a negative map reply. This is a summary of what we saw in this session. We saw that ETRs send map register messages to map servers, and upon receival, map servers will reply back with a map notify message to ETRs. We also saw that ITRs and proxy ITRs will send map requests to map resolvers. If the request is valid, then the map resolver is going to forward this map request to an ETR. So an ETR eventually is going to reply back with a map reply to the original ITR or proxy ITR that sent the map request in the first place. Or if the request is invalid, the map resolver itself is going to reply back with a negative map reply to the original ITR or proxy ITR that made the original map request.